There is a question that has followed humanity since the very first night someone looked up at the sky and felt something they could not name. Not a scientific question, not a mathematical one. Just a quiet, aching, deeply human question. What is all of this? Think about that moment. Think about the very first human, maybe standing on an open plain, fire dying behind them, the whole night sky stretched out above in absolute silence. No cities, no lights, just the stars, billions of them, burning in the dark. And that person, small and fragile and alive, looking up and wondering. That moment has repeated itself billions of times across human history. In every culture, in every language, on every continent. The farmer in ancient Egypt, the sailor navigating open ocean, the child lying on their back in a field on a summer night. We have always looked up, and we have always wondered. We have built telescopes the size of cities to try to answer this question. We have launched probes into the void between stars. We have mapped galaxies billions of light years away. We have split atoms, decoded the language of DNA, and sent human beings to walk on another world. And still, on a clear night, when you tilt your head back and let the darkness wash over you, the question returns. What is all of this? Tonight, we are going to try to answer it. Not with equations, not with textbooks, not with cold data on a screen, with wonder. Everything you see out there is old. Not old the way a mountain is old. Not old the way a fossil buried in ancient rock is old. Old in a way that breaks the human mind completely open. Here is something that sounds simple, but will change the way you see the night sky forever. When you look at a star, you are not seeing it as it is right now. You are seeing it as it was, years, centuries, sometimes thousands of years ago. Because light, fast as it is, still takes time to travel. Light moves at 300,000 kilometers every single second. In the time it takes you to blink, light has already traveled thousands of kilometers. In 1 second, it could circle the entire Earth 7.5 times. And yet the nearest star to our Sun, a small, dim red star called Proxima Centauri, is so unimaginably far away that even traveling at that speed, its light takes more than 4 years to reach us. 4 years of continuous travel, at the fastest speed anything in the universe can move, just to reach our closest neighbor. Now think about the stars you see on a clear night. Some of that light left its source 500 years ago, 1,000 years ago. Some of it began its journey before humans had learned to write, before the pyramids were built, before our civilization existed in any recognizable form. And some of the stars you see tonight, they are already gone. They burned out long ago. What you are seeing is a ghost, an echo of light from something that no longer exists. You are not looking at the sky. You are looking at history. Ancient, luminous, silent history, written in light across the darkness. Now let us talk about scale, because nothing puts a human being in their place quite like honestly confronting the scale of the cosmos. Our sun is enormous. It is so large that over 1 million Earths could fit inside it. If you hollowed it out and tried to fill it with our planet, you would need 1 million copies. The sun's diameter is 109 times that of Earth. Its gravity holds 8 planets, countless moons, asteroids and comets in stable orbit across billions of kilometers. And the sun is a completely average, unremarkable, middle-aged star. Now let us talk about scale, because nothing puts a human being in their place quite like honestly confronting the scale of the cosmos. Our sun is enormous. It is so large that over 1 million Earths could fit inside it. If you hollowed it out and tried to fill it with our planet, you would need 1 million copies. The sun's diameter is 109 times that of Earth. Its gravity holds 8 planets, countless moons, asteroids and comets in stable orbit across billions of kilometers. And the sun is a completely average, unremarkable, middle-aged star. And the Milky Way is just one galaxy, the observable universe, the portion we can actually detect with our instruments. contains an estimated 2 trillion galaxies, each one holding hundreds of billions of stars. Each of those stars potentially surrounded by planets, and each of those planets sitting in the darkness of space, separated from its neighbors by distances so vast they have no human equivalent. When NASA pointed the Hubble Space Telescope at a patch of sky that appeared completely empty, a region of total darkness, no bigger than a grain of sand, held at arm's length, and kept it pointed there for nearly 12 days. They found 10,000 galaxies, in the nothing. In the dark, 10,000 entire galaxies, each one a universe unto itself. The cosmos is not empty, it is overwhelmingly, almost aggressively, impossibly full. And then there are the things that remind us how little we truly understand. At the center of our galaxy, right now, as you watch this, as you breathe, there is a supermassive black hole. We call it Sagittarius asterisk. It has the mass of 4 million suns, collapsed into a single point in space so dense, so extreme, that the laws of physics, as we know them, simply break down. A black hole is a place where gravity wins completely. Nothing escapes, not gas, not dust, not radiation, not even light itself. Cross the boundary called the event horizon, and you have left the observable universe forever. But here is the part that truly bends the mind. Near a black hole, time slows down. Not metaphorically, not as a figure of speech. Physically, measurably, actually slows down. If you could hover just outside the event horizon of a supermassive black hole and somehow survive, a single hour of your experience might correspond to thousands of years passing back on Earth. Einstein predicted this in 1915, over 100 years ago, with nothing but mathematics and imagination. And every experiment we have conducted since has confirmed he was right. Time is not fixed. It is not a constant background against which things happen. It bends. It stretches. It is affected by mass and by speed. The universe does not operate by the rules we find intuitive. It operates by its own rules, rules far stranger and more beautiful than anything we would have invented. And we are only just beginning to read them. Here is perhaps the most extraordinary fact in all of science. Every atom in your body was forged inside a dying star. The iron flowing through your blood right now, it was created in the core of a massive star, billions of years ago, under pressures and temperatures we cannot replicate on Earth. The calcium in your bones, the carbon that forms the backbone of every molecule in your body, the oxygen filling your lungs with every breath you take, none of it was made here. None of it originated on Earth. All of it was born in the nuclear furnaces of ancient stars. Stars that lived out their long lives and then, at the very end, exploded. These explosions, supernovae, are among the most violent events in the known universe. In a matter of seconds, a single dying star can release more energy than our sun will produce in its entire 10 billion year lifetime. The explosion tears the star apart and blasts its material across tens of thousands of light years. And from that scattered stardust, over millions of years, gravity pulls matter back together. New clouds form, new stars ignite, new planets coalesce from the debris. And on at least one of those planets, perhaps on countless others, chemistry slowly, patiently, miraculously assembles itself into something alive. Into something that can breathe, that can think, that can feel. Into you. You are not a visitor in this universe. You are not an observer watching from the outside. You are not separate from the stars you see overhead. You are made of them. Every heartbeat is powered by iron, born in a stellar explosion. Every breath connects you to oxygen that once burned inside a sun. You are, in the most literal and scientific sense possible, a child of the cosmos. We did not come into this universe. We came out of it. And yet, for all its scale, for all its 2 trillion galaxies, and its countless billions of stars, the universe presents us with one of the deepest mysteries we have ever encountered. It is almost completely silent. Since the 1960s, we have been actively listening. Radio telescopes have scanned the sky in search of any signal, any pattern, any transmission, any sign that somewhere out there, another civilization developed technology and reached out into the dark. The search for extraterrestrial intelligence has been ongoing for decades, scanning billions of frequencies, watching billions of stars. So far, nothing. This puzzle has a name. Scientists call it the Fermi paradox, after the physicist Enrico Fermi, who posed a simple and devastating question. Given the age of the universe, and given the sheer number of stars and planets it contains, where is everybody? The universe is nearly 14 billion years old. Even if intelligent life is rare, even if only 1 in a trillion planets produces a technological civilization, the math still suggests we should have heard something by now. We should have seen evidence, some signal, some artifact, something, and yet, silence. The explanations are as unsettling as the mystery itself. Perhaps the development of intelligent life requires such a precise and unlikely chain of events that it has happened only once, here, on this small planet, around this ordinary star. Perhaps civilizations inevitably destroy themselves before they develop the ability to communicate across interstellar distances. Perhaps the universe is full of life, but life that is so different from us that we have no way of recognizing it. Or perhaps, and this is the thought that keeps astronomers awake at night, perhaps we are simply not listening in the right way. Perhaps the signals are there, but we lack the instruments, or the knowledge, or the imagination to detect them. The silence is not proof of emptiness. It is an invitation, urgent, open, and deeply compelling, to keep searching. So what does it mean? What does it mean to be a small, warm, thinking creature on a small, warm planet, orbiting a completely ordinary star, in one unremarkable galaxy among 2 trillion others? Many people confront these numbers and feel crushed by them, insignificant, erased. If the universe is this vast and this old, and this indifferent, what could our brief lives possibly matter? What is the point of anything we do, anything we feel, anything we build or love or lose, when measured against 14 billion years of cosmic history? I understand that feeling. I have felt it myself. But here is what I keep coming back to. In all of those 14 billion years, in all of those 2 trillion galaxies, in all of that incomprehensible scale and silence, the universe has produced something it had never managed before. Something extraordinarily rare, maybe something unique. A creature that looks up and asks why, not just a living thing. Not just something that survives and reproduces, but something that wonders. Something that builds instruments to peer back to the beginning of time. Something that writes poetry about the stars it is made of. Something that grieves and loves and hopes and imagines futures that have not yet arrived. Carl Sagan said it better than anyone ever has. We are a way for the cosmos to know itself. In us, in our curiosity, our science, our art, our love, the universe becomes aware of its own existence. The cosmos, which has no eyes of its own, opens ours and looks back at itself. That is not insignificance. That is the rarest, most precious, most astonishing thing in all of creation. We are at the very beginning of something we cannot yet fully imagine. Our species has existed for roughly 300,000 years, a single heartbeat in the life of the universe. And in just the last few centuries, we have gone from believing the Earth was the center of everything, to understanding that we live on a pale blue dot, orbiting an average star, in the outer edge of one galaxy among trillions. We have walked on the moon. We have sent machines to the edges of our solar system. Machines still traveling through interstellar space right now, carrying a golden record with the sounds of Earth, just in case someone out there is listening. We have photographed a black